when you open Unreal, when you open the demo project, make sure that you have LexTwin plugin. So you don't need LexTwin plugin to use my plugin, but I built my plugin to work with it, to be compatible with it. Okay, so what you need to configure is actually the game mode, not the plugin itself. So go in World Settings, find here the game mode. This is a default game mode that comes with the demo, but it's mostly empty, and you can use your own game mode if you want. So open your game mode. So basically, if you add this to your game mode, it's going to work. This is where you configure the OSC input and outputs. First, the receiving IP is going to be your input, the message, well, what the message you are sending to Unreal. And so I'll just change the IP here to show that it works, and set whatever port you want to use. And this is the OSC clients refers to where you want to send messages from Unreal to Touch Designer or to Ableton, let's say. So anyway, this is actually here. I need 201 for me, like this. All right, so the cube is already animated now because I'm sending from the data. This is what you should see when it works and you have Touch Designer open. So let's switch over to Touch Designer. This is the simple demo project. This demo project combines a few different ways to control the Unreal with OSC. So same thing here. You need to make sure these IPs here match your own IP on this chop here and this that. So those switch, it's only one on off, and it like I manually wrote down like which addresses should be sent, which values should be sent. You obviously you would do this like more procedurally instead of just an on off switch, but this is just a demo. So it shows you like the proper cube one here is the address of our test cube. Matt sends this so it controls the material directly and the color of the material. This is actually the color value, like red with some of those values. And this is the interpolation time. So it's going to interpolate over 0.1 second. And this one is going to interpolate over 1 second. So they don't have the same speed. And we can see like switching to red, like it's much faster because it's doing so in 0.1 second. And same thing for the location. So here, like test cube is right here in the map, and I set it the OSC address is cube1. So if I change this, I'm going to break things. All right, so cube1 message is received here and it's parsed here. Ideally I would change this, but it is what it is for now. So location offset is the message I get when I click here, right? You can see, we can see it being sent here. And part of this address, like it ends with a float that controls the interpolation. And we have the curve type here, like I'm sending 0, I could, which defaults to linear. And when I send 1 second, it's going to trigger this interpolation over 1 second. And this node here allows me to interpolate the cube, well, the root, the actor in this case. And this node comes, these two nodes come from the LexTwin. If you don't want to use that, you can use those values actually and build whatever you want with it. But this plugin is really useful. So that's why I wanted to showcase it in here. Okay, and so the material thing is handled a bit differently. So whatever comes in, whatever address you put after the first address mat is going to be the parameter of that material. So in this case, you only need one branch for all of the parameters of your material. So it's a really effective way to control any parameter right away. So you need, like, I'm building here, the comment explains this, but basically if I'm sending a longer message, it means it's a vector. And if I'm sending a shorter message, it means it's just a float. So I built like an example for each of those. But basically the difference here is that from the plugin, I get to parse my incoming OSC message. And it looks a bit like this. Here I'm receiving a float. I only get one value, which is a float, and I connect it directly to material scalar parameter 2, which is from the LexTwin plugin as well. But when the message is longer, it goes here. You can build this any way you want, by the way. It goes here, and then from this parser, I get, I call it color 3, because I'm only receiving a color, but this value here is actually as the alpha, but the alpha is always going to be 1. And if you're curious, you can also build your own nodes like this. And to do so, basically double click one of them. It's going to open OSC receiver component, which is, by the way, which is right here. And here you can add more. Where are they? Are there? You can build more of those. So I can, this one for instance, okay, so I'll start by explaining this one. So from the message, I get the color RGB. And as you can see, the alpha is always 1. But I also made a color 4 if you need to send the alpha. You get RGB and then the alpha and then the interpolation, like the duration of the animation. And this is a way to pick the ease curve by index.